Good morning, ma'am. Myself Rajita B. I am from CSCE section, and today my topic is matter wave and its properties. Introduction to the matter waves. Matter waves are the fundamental concepts in concepts quantum mechanics. They describe the wave-like behavior of particles such as electrons and atoms. This concept was introduced by Louis de Broglie in the earlier 20th century. De Broglie's hypothesis. Louis de Broglie proposed that all matter has wave properties. The wavelength of the matter wave is inversely proportional to the momentum. This relation is expressed by the equation lambda equals to h by p, where lambda is denoted by the wavelength and h is denoted by the Planck's constant and p is denoted by the momentum. Also p equals to m equals to v. P equals to m into v. M is the mass and v is the velocity. Wave particle duality. Matter wave illustrate that the principle of wave particle duality. Particles can exhibit both wave-like and particle-like properties depending on the experimental setup. The duality is concentrated of quantum mechanics and challenges classical intuitions. Properties of matter waves. Matter waves has properties such as interference and diffractions. This phenomenon demonstrates that the particles can spread out and overlap like waves. Experiments like double slit experiment illustrate these properties validity. The double slit experiment. The double slit experiment showcases wave-like behavior of electrons. When electrons can pass through the slits, they create an interference pattern on the screen. This result indicates that each electron behaves as wave and interferes with itself. When the electrons are passing through the screen with the two slits, optical screen, then it splits into the directions. The double slit experiment showcases when the electrons passes through the slits, they create the interference pattern on the screen. And their results indicate each electron behaves interference with itself. Wave function and probability. Matter waves also described mathematically by wave function in quantum mechanics. The square of the wave function amplitude gives the probability density of finding a particle. This probabilistic interpretation is a key departure from the classical physics. The square of the wave function amplitude gives the probability density finding the from the classical physics. Heisenberg uncertainty principle. The Heisenberg uncertainty principle is closely related to the matter waves. It states that the one cannot simultaneously note both the position and momentum of a particle with the arbitrary precision. This principle arises from the wave nature of particles and their associated wave function. Heisenberg uncertainty principle. The electrons are revolving around the nucleus. Delta x into delta p greater than or equals to h by 4 pi, where delta x is equals to change of the electron, delta p is equals to change of the electrons, h is equals to Planck's constant. Quantum tunneling. Quantum tunneling is a phenomenon where particles can pass in through the potential barriers. This barrier behavior is explained by wave-like properties of matter waves. Tunneling is crucial in process like nuclear fusion and semiconductors technology. Applications of matter waves. Matter waves highly significant implications in fields like quantum computing and nanotechnology. They are utilized in electron microscopy, allowing for imaging at atomic scales. Understanding matter waves is essential for advancement in quantum mechanics and materials science. Conclusion. Matter waves are fundamental aspects of quantum physics that challenges classical notions. Their properties such as interference and tunneling have profound implications in technology and science. Understanding matter waves depends on comprehension of the quantum world and its application. Feel free to thank you, ma'am.